The other way I noticed that we need to do a substitution is I have kind of a funky power here, and this is whatever this is squared. So I'm going to take whatever that middle term is, and I'm going to have that be my kind of default state. So I use this w to the 1/2 because I really don't like him. And I would like to swap him out. W to the 1/2 is going to be my u. I'm going to redraw that u because that u looked weird. There we go. And then what I'd really like to happen, and this should happen when we have a quadratic type, is if I take my w to the 1/2 and I square it, because that would be our u squared, what happens when we have w to the 1/2 squared? What do we get? W. And that is exactly what we got from our u term that was squared. So I can use this information with this information to make this less gross. We use this guy as our jumping off point to figure these two pieces out. If we have a quadratic type, this should always happen to be these two terms. Because then I can swap this out to be 6, instead of w, it's 6u squared plus 7u minus 20. And this is way easier to deal with. Like, we know how to deal with these. We've worked with them before. It's a quadratic. How do I find my answer for u? We can factor this one. This one is fully factorable. We don't have a GCF, so it's not going to be easy for us that way, but we can factor this the traditional way. 6 times negative 20 gives us negative 120. Our b is 7. We need a pair of numbers that multiplies to make negative 120 and adds to be 7. 15 and negative 8. So again, I don't care how we factor, just that we factor. I'm going to do grouping up here with our 6u squared minus 8u plus 15u minus 20, 0. I'm going to bust mine into pairs, keeping a plus in between. And I can have a 2u taken out here, leaving us with 3u minus 4. And I can take a 5 out of the middle one, or the next one, leaving me again with a 3u minus 4. So our factored form here, I'm just going to change my view real quick. When we get this in factored form, we have our 3u minus 4 and our 2u plus 5. Questions on that bit? We're done up to here. Okay, because the next thing we can do is we can find our solutions for u, for whatever u equals. What is u going to equal? So from this one we get u equals positive 4/3. And u equals negative 5/2. Awesome. We've got solutions. Just for the wrong letter. Because we didn't start out with u's. We started with w's. So, yeah, great. We know what u equals, but I wasn't asked what u equals. I was asked what w equals. So now we've got to switch it back. And we know that u equals w to the 1/2. I do highly recommend writing this off to the side so that you remember what the heck u stands for. I find writing this very helpful, but you have to have this one down here. We need to know it. So we're going to swap our u back out for our w to the 1/2 equals 4/3. And our w to the 1/2 that equals negative 5 halves. So how do we figure out what our W is? I was like, it's not W times 1/2, it's W to the power of 1/2. Only if we have negative exponents. We don't have negatives. What does a 1/2 exponent mean? Square root. So this is the same thing as saying the square root of W equals 4/3. And the square root of W equals negative 5 halves. So when in doubt, switch it to be rational roots like this. Because now what do we see? Say it again, just my brain didn't process. Square both sides. So we get W equals 4 squared is 16. 3 squared is 9. 16 over 9. Is the square root of W going to equal a negative number?
No.
Because if we had, that's not going to happen. So this is going to be an extraneous answer here. If we wind up with radicals equal to negatives, we can't do that. Anything squared is going to be positive. So it's not giving us a complex answer. This just doesn't happen. This one is extraneous. We cannot have a square root that equals a negative number. We could square both sides and get to an answer and then substitute it back in to check that. But if we start to notice that with square roots, if I'm given a square root and it's set equal to a negative number, that's not going to happen. That's going to be extraneous. If we had an odd root, then we could take it. Like we were taking a cube root, we can take the cube root of a negative number. But I can't take the square root. I'm never going to have a square root that equals a negative number. Okay, I want to do another one like these because these are weird and they just take some practice and they're awkward. We're going to do another one like it. Questions on this one? Let me get the whole thing up here. It is going to be not super duper often that we wind up with extraneous answers. Most of the time we're actually going to get answers on these. It's not super duper common. Let's try another one. This is our last one of these quadratic types. This is the very end of 2-5. Help. Okay. All right, so what we have is our 3x to the 2/3 plus 4x to the 1/3 minus 4, all set equal to 0. We know it's a quadratic type partly because of the instructions, but we can also look here and see, well, this is x to the 1/3 and this is 2/3. So this is square root of each other. But I don't want to have to deal with x to the 1/3 as it sits right here, so I'm going to substitute it out. I want my u to be whatever my middle term is. X to the 1/3. And then we should have that our u squared, which we know is going to be our x to the 1/3, which is our u, squared, should equal, when we have powers raised to powers, we multiply them. 1/3 times 2 gives us x to the 2/3. if it was 1/3 times 1/3, so if it was 1/3 squared, then it would be 1/9. But when we have powers raised to powers, we multiply them together. So just like if I had x squared times x squared, it would be not doing squares, x squared times x cubed, we would end up with x to the 5th. But if I had x squared cubed, we'd have x to the 6th. We multiply them. It's just sometimes harder to remember with the fractions because we really, really would rather square them. But that gives me significantly better numbers because I can see that this guy is exactly what we have here. So I can rewrite this as my 3u squared plus 4 times my u minus 4 equals 0. And this now becomes way less obnoxious to deal with because we can factor this. We have what we need. All the information is here. This does factor. It does not have a GCF, but it does factor. I'll put it up here. I know a lot of you are flying ahead because as soon as we switched out the u's to u squareds, y'all went head down, started flying, which is totally fine. That's part of the reason sometimes I don't say it out loud when I'm writing it because I know you guys are working ahead, which is totally fine. A pair of numbers that multiplies to make -12 and adds to make 4, 6 and -2. So we'll have our 3u squared minus 2u plus 6u minus 4. Be really careful when you're doing this. If you do it with grouping, make sure you're putting the middle term or u here. Don't randomly switch it to x's. You'll get confused. Because then we're going to factor it. And again, I don't care how we factor, just that we factor. I'm going to do mine with grouping. Nope. 2. U minus 2. So our factored form is going to be our u plus 2 and our 3u minus 2. So we should be able to get down into this factored form. What do we get as our solutions for what u equals? U equals -2 and u equals +2/3. Exactly right. But again, we weren't asked about u, we were asked about x. So we got to switch them back in. We have x to the 1/3 is what our u was. So this is really x to the 1/3 equals -2. And x to the 1/3 equals 2/3. How do we get rid of that power of 1/3? You can absolutely convert it down into roots. What kind of root is this? Cube root. So if it helps, absolutely do so. You don't have to write it like this, but this is in fact the cube root of x equals -2. So what do we do to get rid of the cube root? Cube it. We raise it to the 3rd power. We raise it to the 3rd. Also, if you think about it from here, our 1/3 times 3 gives us our 1 exponent. So you can do it from the fractions because 1/3 times 3 is 1. But what we get for x on this guy is what? What is -2 cubed? -8. It is okay to have negatives on cubes. Odd degreed functions, odd powers, keep their signs. So then what do we get for our other one? We cube our other solution. What do we get? 8 over 3 cubed is 27. Okay. Let me zoom out so we can see the whole thing. So these quadratic type problems are a little finicky and weird and awkward. Questions? Okay. Because that is the end of 2.5. That is everything in 2.5. Okay. Those quadratic type ones are weird and awkward, but they just kind of take some practice. So we are going to start on section 2.6. So this is going to be another one of those where we have the big jump from the hardest one in 2.5 to the easiest one in 2.6. So it's going to be like a big scene change here. Because we're going to talk about some inequalities. For our inequalities, I'm going to give you guys a thing to glue in because we need to talk about some notation real quick. So I have this little table for you. You don't have to make it. Just grabbing the boxes that have the glue sticks. I'm grabbing the Jenga tower that has the glue sticks. So you don't have to glue it in, but I'm giving you the option of it. I will grab more. So this is the exact copy of the table we have up here. And what we're going to have is we're going to be dealing with inequalities in 2.6. And we will wind up working with inequalities a good chunk of the year. So we have a couple of, like, it's going to feel like weird things, but it is relevant things we're going to do with them. Because we're going to deal with inequalities and things like quadratics and when we get there, like polynomials. Scissors and stuff, if you want to trim up you can, but try to get them cut out as good. Oh, sorry. I'm really good. Okay, so this is the exact copy of the table that we have up here. Actually, these were not. Fourth grade. And what we're going to do is we're going to start by writing these in our interval notation. If you have a dead glue stick, let me know. I have tons more.
You need another one.
Got it. I say these ones are still left over from last year. So I have not even busted into the new ones yet. So more glue sticks. If you have a glue stick that is dead, please throw it away. And then we're going to glue these in. And what we're going to do is we're going to start by trying to write these in interval notation.
Yep.
And then we're also going to draw them on a number line. So what I mean is, if we say that x is between a and b, a is less than x, which is less than b. Our interval, where this is true, is going to start at a and go to b. We use parentheses when it's not equal to. The only difference between the first one and the second one is that it has these equal to's. I've got a is less than or equal to x, which is less than or equal to b. And in that case, we're going to use those square brackets. And yes, I will be petty about which one you use. It does matter. If we have an equals to, we use the square brackets. If we do not have an equals to, we use parentheses. These ones I can touch. The parentheses, I think it's a noxious little sibling going, I'm not touching you, I'm not touching you, I'm not touching you. It's getting really, really close, but it's not technically touching it. Because if we were to do this on the number line, I'm just doing these first two together, and then I'm going to give us some time to think on it. If we were to put these on like a number line, and we know A is smaller than B because of the way these things are shaped, A is smaller than B, and X is somewhere in between, I would want to put open circles on A and B because we know x gets real close to them but can't be equal to. And then all of our answers are where x is between. So this would be where our solutions are. What's going to be different on the second line? Closed circles. Only thing different between a less than and a less than and equal to on the number line is we've colored in the dot because now I can equal B. When we have those less thans or open circles, I like to think of them as kind of like a lava pit. You got to jump over it. I cannot touch B or I'll catch on fire. Ow. 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 It hurts. He's got a cover on it. They put a manhole cover on this lava pit. I can walk on it. Okay, so when we have something where x is less than or equal to A, so the very next one. I'm going to draw this one actually on the number line first. So we don't have anything about B on here. We just have anything about A. If I know that x needs to be less than or equal to A, am I going to do a closed circle or an open circle at A? Closed. Which way am I going to shade? To the left or to the right?
Left.
Left, because x needs to be less than. When do I stop? Never. So on my interval, what's the left side of my interval going to be? Negative infinity. This goes all the way down to negative infinity. Am I going to put a square bracket on negative infinity or a parentheses?
Parentheses.
Why?
Because we can't really actually.
Because I can't touch infinity. It's an idea, not a number. I cannot touch infinity, ever. So we will never put a square bracket on infinity. Am I going to put a square bracket or a parentheses on the A?
Square bracket.
Square. If I can touch it, we get a square bracket. If I cannot touch it, we get parentheses. So it's very, very similar for the next one. The only difference is, instead of it being less than or equal to, we just have a less than. So I still would have my number line. I would still have my A here in the middle. The only difference is going to be we would have an open circle, but it would still go to the left. So we would still have our negative infinity, and this time it goes up to A, but we use our parentheses because I cannot equal A directly. I'm sure I get these packed up like that. I want you guys to have all your stuff. Also, my day is getting incredibly long. So when we look at our x being greater than or equal to B, I'm again going to start on my number line on this one so we can think about it. We know we're going to be centered at B, so I kind of put that one in the middle. Am I doing an open circle or a closed circle on this one? Closed. Which way am I going to color? To the right. When do I stop? Never. I'm not hitting any walls. X can be bigger than B. It could be 10 bigger, 100 bigger, 1,000 bigger, 1,000,000 bigger, 547,843 bigger. Doesn't matter. So what is our interval going to be? B to infinity. Does B get a square bracket or parenthesis? Bracket. Infinity? Parenthesis every time, because infinity is an idea. Also, we can't go beyond it. Buzz Lightyear's wrong. Because we can't go to infinity and beyond. Because we can't go beyond infinity. And spoiling the Disney magic. Oh well. So see what we can come up with for the next two. See what we got. The third one is like extra. So the third one's a little extra weird. That was the very first one.
I did the wrong question.
That's all the things I have up to now. So for our next one here, what is our interval? For x is greater than b, what's our interval? From b to infinity. But this time it's going to have a parentheses over here. The only thing different between this one and the one above it is that our b gets an open circle. Other than that, it's the same. Oh, that was a trash arrow. Whoa, that hit the whole line. There we go. So we just have our open circle right at the b. What about this next one? A is less than x, which is less than or equal to b. What are we going to do on this one? If it helps, draw it on the number line first. We know we're going to have A and B. Are we going to do an open circle or a closed circle at A? Open. Are we going to do an open circle or a closed circle at B?
Closed.
Closed. And are we going to color between them or away from them? Between them. So our interval, the low end is A, the high end is B. We're going from A to B. A, is it going to get a parenthesis or a bracket?
Sure.
Parenthesis. B, is it going to get a parenthesis or bracket?
Bracket.
Bracket. So we can have mixed pieces. I could have a bracket on the first, parenthesis on the second. I could have a bracket on the front, parenthesis on the second. Doesn't matter. What about the last one? What do you think about this? I have negative infinity, which is less than x, which is less than infinity.
Why does A have parentheses?
Because it was not equals to. If it was equals to is when we get a bracket. No, good question, good question. Mm-hmm. Yeah, my x is in the middle here. I know my x needs to be bigger than negative infinity and smaller than infinity. But do we know anything else about it?
No.
It's everything. And there's no chance of x equaling infinity, so it will never say less than or equal to infinity because we can't equal infinity because infinity is an idea. But this is just saying we're going to go from negative infinity to positive infinity. Means our answers could be anything in the whole wide world. All real numbers would be another way to say that. This is technically our interval notation, but I would also take it. It works. Okay, so our answers when we're dealing with inequalities are going to look like this. We're going to get an interval. We don't necessarily have to draw things on a number line, but especially when we're getting started, it does sometimes help us spot which direction it's going. And when we get into like bigger things, we're going to use a line of a kind.
Oh God.
I'll walk us through it, I promise. Anybody need more time on this page? I just want to make sure we got it down. Okay, because we're going to work with some inequalities, and we're going to solve them. And again, remember, we went from the hardest one of 2-5 to the easiest ones in 2-6. We're going to be given an inequality and asked to solve it. We are not just going to get one answer here anymore, or 2 answers, or 3 answers. We're going to get a whole inequality as our answer. So our answer is going to be an interval. So if we're given 3x plus 8 is less than 7, what do we need to do first? How do we solve this and figure out what x is?
Do we treat it like
Treat it like an equation. The only time it's going to be treated anything different than an equation is if we multiply or divide by a negative number. Because when we multiply or divide by a negative number, what happens to our inequality sign? Flips. That's the only time that's going to change, is if we multiply or divide by a negative number. So what am I going to do first here to try and figure out what x is? Subtract 8. So we're going to get our 3x is less than negative 1. What do we do next? Divide by 3. Am I dividing by a negative number or a positive number?
positive?
Positive. So is my sign going to change? No. Only if we multiply or divide by a negative number. So our x is going to be less than negative 1/3. But we're not going to write our answer like that. We're going to put it as an interval, which means we need to know, smallest to biggest, what's happening here. We can look at that little table we have, because we see what x less than a looked like. Or we can kind of sketch it on a number line. I'm going to do green. To think about it, I know negative 1/3 is an important piece here. Would we have an open circle or a closed circle at negative 1/3?
Open.
Open. And which way would we go? To the left. X needs to be smaller than. So things that are smaller than would be like negative 1, negative 2, negative 20, negative 500, negative 4 million. What is our interval going to be? From negative infinity up to negative 1/3. Negative infinity always gets a parenthesis. Our negative 1/3, is that going to have a parenthesis or a bracket?
Parentheses.
Parenthesis. That's our answer. The interval is our answer. Because it could be anything from negative 1/3 all the way down to negative infinity. Negative 1, negative 20, negative 5 million. Anything in that region would make this true. The next one that we see, we got fractions, ew. You can rock it with the fractions, that's totally fine. Or you can get rid of them. What do we want to do? How would we approach this? Don't say cry.
I was gonna say go to sleep.
Don't do that either. I know we look at this and we go, ew, fractions. Ugh. How do I get rid of a fraction? Multiply by the denominator. So what should I multiply by? We can multiply by 3. We can multiply by 5. We could multiply by 15 and get them both gone. I'll do it individually because I heard 3 and 5 first. So if I multiply both sides by 3, that's going to give us 3/5 x plus 12. I multiplied by a positive number, so my sign's staying exactly where it was. And here's where we get the benefit of multiplying by 3. Oh, because 1/3 times 3 gives me 1. So this is just 1x. Oh, that's better. Minus 21. I still have one fraction, and we don't like it, so I would really like to multiply also by the 5. And again, you could do this in one chunk by multiplying by 15, or you can do it in 2 chunks. But whenever we have fractions, don't just give up. You can rock it with the fraction and get to a common denominator and get the exact same answer. It's just most of us tend to go, never mind, and leave. But then we're going to have our 3x plus 60. Again, we multiplied by a positive number, so my sign doesn't change, and we get 5x minus 105. This is much better to look at. This is much better to work with. Even though the numbers are way bigger, we're much more comfortable without the fractions there. So when we have fractions, multiply by your denominator. Because now what do we do? You could absolutely subtract the 60. That'd be fine. I'm going to try and avoid having a negative x, though. So which x should we move? Move the 3x. I'm going to subtract the 3x. I do recommend moving your variables first, just because that will keep us from winding up with negatives much. It's not wrong to subtract the 60. That's totally fine. You will just wind up with a sign flip then. So we're going to wind up here with our 60 is greater than or equal to 2x minus 105. What are we going to do next? Add the 105. So then we're going to get our 165, which is greater than or equal to 2x. So what's x going to be? 82.5. Yeah, 82.5 or 165 over 2. And our sign didn't change because we multiplied by a positive number. So if we know that 82.5 is going to be greater than or equal to x, what is our interval going to? Is x bigger than or smaller than 82.5? When your x is on the wrong side, be really careful, because I have my 82.5 and my x can equal or be smaller. So our interval is going to go from negative infinity up to that 82.5 or 165 over 2. I do not care if you do it as decimal or fraction. We're going to have our square bracket on our 82.5 and a parenthesis on our negative infinity. Okay. Questions on these two?
I got that with fraction form.
Totally fine. Absolutely fine. It does not matter to me if you do it in fraction or if you do it as decimal. We're going to stop right there because we have 2 minutes. I'm not going to run us past the bell. I'm going to put this up here just as our little reminder. So since we did some more of those quadratic type problems, 2-5, it's not due till tomorrow. We do also have a quiz tomorrow. Over to 3, 2-4, 2-5. That is also part of the reason I gave you back all your homeworks. I have all the answer keys should be up. Let me double check that 2-5 is up, because I'm going to put the answer key up for 2-5 as well, so that you can look at it and double check things, because we have the quiz tomorrow. So I'm not concerned about that. Right now, as of right now, every single answer key is up for everything up through 2-5, including 2-5. So you can look at it, see all the notes, see how I did it, all that jazz, as you're studying and getting ready for tomorrow. Okay? 2-6 isn't due until next week, so focus on getting ready for that quiz. Okay? We've got this. Say it again. 23, 24, 25. That's part of the reason I gave you guys back all the everything, so you guys have everything that you've done on it. So if you're one of my people who turned in 25 and you want to take it back, so that you can look at it and check it on stuff, that's totally fine. Totally fine. It's not due till tomorrow anyway. It won't be marked late. You're good. If you're still working on 25, totally valid. Okay. Make sure you are doing the IU registration. We need to get that in hopefully by the end of next week. I will pull up my list next week and see how many people I got in there. Last time I looked, it was 10.